11, which is our forensic toxicology unit. It's kind of lengthy, but it kind of mixes up with Unit 12, which deals with controlled substances. Okay, so let's talk a little background. I'm going to give you the bonus question that you'll see on the unit exam now, so you'll have plenty of time to practice it. And this guy, he is our father of toxicology. He is the coolest person I've ever met in college that's been dead for a few hundred years. His name is Philippus Aurelius Theophrastus Bombastus von Hohenheim. Yeah, try saying that 5 times fast. Well, lucky for you, all you have to do is write his name on the test and you get bonus points. 1 point for every word, so 1 point for Philippus, 1 for Aurelius, 1 for Theophrastus Bombastus von Hohenheim. Now, I will tell you this. If you don't spell it correctly, you don't get the point. You guys get offended when we spell your names wrong? I'm pretty sure he would too. Now, this guy, Lord knows he had a long name, so we're all kind of mad at his mama. He went by a different name. He called himself Paracelsus, which basically means next to Celsus. Celsus was a pretty smart guy for his time, and we don't have to really get into him because we're focused mostly on Paracelsus. He was a Swiss-German Renaissance physician. He was a botanist, an alchemist, an astrologer, and a general occultist, which basically means he just dabbled in the different sciences. He tried to make, ordinary junk into gold. He looked at plant lifespans. He was a doctor. He just had his hands in everything. And he lived from around 1443 to 1531. So that's as much as I need you to know about our good friend Philippus Aurelius Theophrastus Bombastus von Hohenheim, also known as Paracelsus. That's all you need to know for the unit exam. Now, a lot of you may be confusing our father of toxicology with the father of modern forensic toxicology. His name was Matthew Orfila. We learned about him earlier this year. He lived from 1787 to 1853. Now, he was a pretty cool guy because he was the one who actually detected arsenic in corpses and then testified about it in court. Okay, so don't get those two mixed up. So let's talk about the role of forensic toxicology. First off, toxicology is the study of drugs and poisons and how they affect our body. We are looking at everything from what we consider legal drugs, which are the Tylenols that you can get over the counter, to the illegal drugs. And we will talk more about those drugs themselves in Unit 12, which deals with controlled substances. And in case you didn't know, a drug is a natural or synthetic substance that's going to produce some type of physiological or psychological effect on the body. And then forensic toxicology is how we look at toxicology and applying it to the law, which includes workforce or drug testing, which if you guys are in sports or UIL competing events, you get drug tested randomly, you get drug tested for workplace hirement. People who have died and we're not quite sure how they died, we do a forensic toxicology assessment on them. And then finally, human performance testing, which I'm pretty sure, seeing that the Olympics begin this week, they'll be doing a lot of performance testing to make sure that the athletes are not blood doping. Now, we want to focus on, right now, the toxicology of alcohol. And these are just some stats for you. About 40% of traffic deaths are alcohol related. Now, these stats are a bit old. This was from 2012, and I'm sure the numbers are the same, if not higher. We have to figure out a way to test and measure degree of intoxication, and then whatever way we come up with must be defendable within the framework of the legal system. And we're actually going to talk about some of these field sobriety exams to determine their reliability when it comes to determining how much alcohol is in someone's system. Now, there are some methods when we need to talk about alcohol toxicology, and it deals with metabolism, and that includes the ability to break down in 3 specific steps. First, we have to absorb it into our body, and we absorb it, and it's going to be delivered via distribution in our bloodstream. Your blood goes everywhere in the body, so therefore the chemical is going to go everywhere. And then finally, how do we get rid of it? And our kidneys and our digestive system are the way we get rid of toxins in our body. Now, when we come to alcohol absorption, alcohol appears in the blood just minutes after consumption. A lot of people think that they can drink slowly or quickly and it takes longer for the body to absorb it, but realistically, it's being absorbed the moment it gets into your body. And it is carried because of the bloodstream to all parts of the body. When it comes to distribution, I like that little effect. I'm trying it out for the first time. Because it is traveling in the bloodstream, it's going to go anywhere where there is going to be some water movement, so within and out of cells and other organ systems. There are some factors that can affect the absorption and distribution, of course, and we're going to talk about those. We have to look at the speed of consumption. Are you drinking 1 6-ounce glass of wine over 2 hours, or are you chugging your liquid? We also have to look at the percent of alcohol content. Is it a high percentage, which means it's very toxic, or is it a low percentage, which means it's not going to have as quick of an effect because the toxicity level is lower? And then we have to look at the quantity. Are you drinking 6 ounces or 60 ounces? That is definitely an issue we need to look at. And then also, last but not least, what kind of food and what type of food you have in your stomach. There are plenty of old wives' tales that say you need to pad your stomach with bread and tomato products or milk to help line the stomach. Either way, they will eventually end up in the bloodstream. So don't think that any one item is going to keep the alcohol from entering your bloodstream and distributing throughout the body. Elimination, it's a pretty simple process. It's how we get rid of things. We do it one of 2 ways. It's oxidation, which occurs in the liver. If you have too much alcohol over too long of a period of time, you tend to see oxidation of the liver or sclerosis of the liver, and then you are on the list for a liver transplant. And then finally, excretion through breath, urine, and perspiration. You can sweat it out, you can breathe it out in your mouth, or you can pee it out. Now, we use the breath in a field sobriety for the breathalyzer. They can also test your urine, which is kind of what we do for blood testing or drug testing in the district, and then also through sweat. This is just a little or a picture just to kind of show you where it happens. Absorption, 80% of it is in the intestine because that is the longest part of the digestive system, 20% in the stomach. When it is distributed, you have to remember it is going to the brain at some point or time. When it comes to elimination, 3% comes from your breath, sweat, urine, and feces, and then 97% of that metabolism happens in your liver and kidneys. All right, so that is it for today's lesson. So it's our wrap up, and I just want to know what percentage of alcohol is absorbed in the stomach.